compare what the top 10 is, and then just go over some of those risks. So should be fun, should be interactive. I don't see any reason why we can't interrupt and ask questions. All right, so who uses Kubernetes? I know most people, yes, no. There's a lot going on inside of a Kubernetes cluster, right? And my career took me to Kubernetes when the project was at 0.8. I was at a company that decided to YOLO it into prod, and it didn't have RBAC. We shared a cluster admin credential on like a sheet of paper, and we built it using Chef on some EC2 instances. I don't know why, but since then I just haven't stopped dealing with it and enjoying it. And if anything, it's been an interesting journey to see how difficult it is to secure. So today we're going to talk about some of the things that I've observed and others also. And OWASP has other Kubernetes Docker things. It's not just the OWASP top 10 for like web app risks, right? There's like a million, you could do a top 10 for the top 10s at this point. There's LLMs, all sorts of things. I contributed to the Kubernetes security testing guide and the cheat sheet, and now the top 10. So there's a whole suite of things around the container infrastructure space. So if you don't know what Kubernetes is, it's a container orchestrator, and what that basically means is a place to run containers. Whether they're it's if you've done anything with Docker or any of the tools that are out there, it helps you run those at scale, and with that comes some challenges. We often call Kubernetes kind of a data center inside of a data center. You have networking, you have secrets management, access control, just regular old patching. All that stuff is a little different in Kubernetes. It's not impossible, but it's there, and it's not really looked at with a microscope like it should be. So people are abusing this already, contrary to what you may see in some news articles. There are breaches, there are ecosystem CVEs, some of the fun ones as of late in Run C, which always seems to have problems. In every time Run C has a problem, that means container breakout happens and you have to run around and patch things. GKE just had an awesome RBAC, I don't even know, hiccup or something, where like G Suite credentials could be used to log into public-facing GKE Kubernetes APIs. That was a fun one. Jenkins always has problems. We also have seen actual campaigns, right? Like for some reason, cryptocurrency miners are always the end goal. People want to install them in Kubernetes, and go figure. So we see Dero Miner, RBAC Buster was a really interesting abuse of RBAC as well. So, the theme is like, this is increasing, so probably a good idea to get ahead of it. And this is the top 10. And since this was published, it's been amazing to watch other people expand on this, and not just in the project, but you'll find blog posts and all sorts of different things. And here's your list. Take a picture, then you can just call it a day, we're good. And the order of this is what is personal to me. No one's ever challenged it, so feel free to challenge it. This is just my observation over the years of like what's important, but everything's kind of top of mind for me. So we'll start with insecure workload configurations. Misconfiguration basically tops every list of problems every year, always and forever, because it's hard. Kubernetes is no different, and people are actively misconfiguring their clusters. Big surprise, right? Surveys will tell you that, but also real life experience will tell you that. And what is a misconfiguration in Kubernetes? Well, if you look at a container, which you're really at the end of the day just trying to get a container or multiple containers running with a certain set of configuration, you can make it do some weird stuff, right? You can tell it to ignore all of the isolation mechanisms that your container runtime provides by giving it privilege. Or you can tell it to mount files from the host file system, from the node itself. You can run the container as root. You can do all sorts of wacky things. And some of those are necessary, but others are really dangerous. So that is what we mean when we talk about like workload misconfiguration. Here you can see we have running as a root user versus a non-root user, and explicitly setting a read-only root file system. Like those are just some examples. So how do we fix this? There's policy management these days, right? And policies are really there to help us audit our clusters and find these workloads. We can do this in CI. You can do it in your developer IDE, or you can do it while the container is running, and you can assess that manifest. So Open Policy Agent is a de facto. It's used in a lot of places. There are other options, such as Kubernetes. There's some in JavaScript. It depends on how you want to write your policies. OPA uses Rego, but really, at the end of the day, you need to have some sort of enforcement mechanism here, where you have to go find these misconfigurations, apply these, and ultimately block them. So the Gatekeeper project is a good open source tool to do that. And number two, it wouldn't be a security talk unless the word supply chain came up. So the supply chain vulnerabilities, right? So the supply chain in Kubernetes is pretty interesting. Containers themselves are changing a lot. They have, different mechanisms to build your container. They go through different CI/CD pipelines. They morph. You're getting third-party software from some vendor over here, building a package over here, and then the Kubernetes cluster itself is just a bunch of third-party code. So the supply chain is pretty important in Kubernetes and elsewhere. So from a prevention standpoint, I think this is a pretty immature space still. We have things like image signing, with cosign, where we're, have this whole certificate authority, and we're, verifying that the image that you're running is correct through signatures. Image composition, our favorite acronym, SBOM, right? We've all probably dealt with this. These things all contribute to a better supply chain story, but they're not perfect, right? We did just release an open source project with an attempt to fingerprint through runtime behaviors open source images. So you can check this out. This is a catalog of open source images, and basically we're using eBPF to understand the behavior, codify it in this giant JSON file, and reuse that. And that's available at rad.security/catalog. And that's one part of the supply chain, right? So go check that out. That's something we built and we're really excited about. And probably the one that should be higher now these days is number 3, overly permissive RBAC configuration. Has anybody wrangled RBAC in Kubernetes, dealt with it? Yeah, well, you're a pen tester, right? So what's your, have you abused RBAC in your pen testing endeavors?
I've been doing mostly AppSec stuff. So
okay, yeah. Oh, like in applications, RBAC configuration. Yeah, so RBAC in Kubernetes, role-based access control, is a unique unicorn, and it is how we provide granular access to resources through the Kubernetes API. We've all used kubectl, right? Probably, maybe. Anytime you make a call via kubectl, ultimately you're authenticated, then you're authorized using RBAC to perform that action. Well, it turns out it's not that easy to configure this. As we saw earlier with all of the issues in actual breaches and notable issues that are going on. And RBAC really is about joining subjects, a group, a user, a service account, to, when you scoping those to verbs and objects. So if I do kubectl get pods, all namespaces, there's a lot of things that have to happen right from an RBAC perspective to allow that. And then, that versus kubectl read secrets or get secrets, that's different, right? So all of these things are assessed by the Kubernetes API, and they're defined by you as the user. So what you see here is called a cluster role binding. Does anybody know what this would do by reading this cluster role binding? Have an idea if this is good, bad, indifferent, scary?
Bad.
Bad, why is it bad?
Cluster admin from default service account.
Yeah, boy, that sounds fine. I could get my job done.
Yeah.
Okay.
And everybody else can too.
Yeah, exactly. So this is a bad example, because cluster admin is a built-in cluster role. it sounds bad, right? It's just cluster admin. And what this is doing is binding that particular cluster role to what we call the default service account. Anybody know what the default service account and the default namespace does? No? Well, I mean, it shouldn't do anything, it actually shouldn't be there, but Kubernetes is going to place the service account tokens or these values in every namespace by default, and they don't do anything unless you have a binding to them. But this is saying that in the default namespace, we're going to give this token cluster admin, right? And this is really bad behavior, but if you paste this code into GitHub, you think you'll find something that looks just like this? It's probably where I got it. There's a bunch of open source projects using Helm or what have you that are gonna set you up like this from an RBAC standpoint, right? Where, really like from an attacker's perspective, if you think about an application running in the default namespace that gets owned, whether it's remote code execution, whether it's, even SSRF or some other sort of like web app attack. And if they can grab this service account, which is just in the path of the file system, they can authenticate to the Kubernetes API and do anything they want. Create secrets, create pods, install cryptocurrency miners. RBAC Buster worked kind of like this. And this would go largely unnoticed. If you just did Helm install, just smashing away and just going to prod, you're gonna create things like this, right? And I think it's nuanced because it's kind of decoupled. The configuration is not easy to see in one place. And it gets worse. Like cluster admin is a very simple example, but you start talking about, actual verbs and excessive permissions, it becomes a real problem, right? And we actually saw this week a whole, I think it was an NSA that published one of the APT groups that was involved in SolarWinds. They're on a whole campaign on unused service accounts. That's like their big target for this year. I don't know, maybe they have OKRs, this APT group, but that's what they're doing this year. And they were already seeing evidence of that in cloud environments, right? So think like an IAM role that's unused, sitting around, same difference except in Kubernetes. And it's a little closer to your web application. So it's almost like a little scarier. So that makes a pretty high risk in my mind, at least. And then the verb, this is a little hard to see, but the verb object configuration is really tricky. And this is just the difference between the get and list command when applied to secrets. So if you look up top, this is running a curl command against the Kubernetes API. This is actually a contribution to the top 10 from somebody else. And I was like, this is amazing. Thank you for doing this. He put this whole case study together. But if you run a curl against the API, you're going to be forbidden when RBAC is set up a certain way, right? I want to get secrets, the top is list secrets. The bottom is doing a get on the same endpoint, and you can see that you're able to print out the secret values, right? And when you wouldn't really expect that to happen. It's just a demonstration. This is built into Kubernetes. This is not an exploit or a 0-day or a CVE or anything like that. It's just how it works. But if you're using the CLI and kubectl, you would never notice this. And there's other examples of it as well. So preventing this is tough. Some people say, I'm just not going to give anyone access to Kubernetes. But that's not the reality in most organizations. You're going to have to give developers access. You're going to need service accounts. Istio needs a service account. Datadog needs a service account. These third-party tools you probably have running in the clusters have service accounts, and humans also access the cluster. I would recommend not using the service account outside of the cluster, right? It's not meant to be used outside of the cluster. Some people, I don't know, I hope this doesn't happen anymore. They'll just throw it in like a GitHub action and authenticate to the Kubernetes API from outside. It's a little dangerous. It's a long-lived token, not really the right way to do it. And you can just tell Kubernetes to stop automatically mounting service accounts inside of any namespace, and that's highly recommended as well. And audit the RBAC of the stuff you're installing. We got challenged today, can we audit KSOC's RBAC? And I was like, yes, please do. you should be looking at your vendors RBAC, like everybody's gonna ask for more than they need, right? In case someday they need to expand. And if you can limit the scope by using role bindings instead of cluster role bindings, that's good also. Kubernetes also gives you really rich audit logs. And you can take those audit logs and look for anomalies and do a variety of different actions on those audit logs to limit the scope and blast radius. Any questions? I don't want to just be talking. Good? All right. We've built some visualizations in our tooling to do this because it drives me nuts that it doesn't exist in Kubernetes. So there's a variety of preventions out there, and we're working on more. So number 4, lack of centralized policy enforcement, centralized with an S. It's the last person to present this, lived in London. Our engineering team is like, a bunch of them are in London and everything is messed up from a S and Z perspective. So here we are. Centralized policy enforcement would be the distribution and governance of policy, right? You're gonna find misconfigurations, great. But how do we detect, remediate, and like find these things earlier and block them? And you can do this in CI, you can do this, in the cluster, you can do this at a mission control. But the key is you have to do it, right? You have to pick some policies that matter to you and your cluster, and your security posture, and push it out. This is a one-liner that's kind of stood the test of time from 2019 from like my buddy Duffy. It fits in a tweet, which is why it's so epic, but this is container breakout, right? If you copy and paste this into your terminal and this works, you don't have any policy governance, right? Like this is saying essentially the last line is kind of the kicker, right? Security context privilege true. If you've kind of like seen any of the previous examples, this is creating a pod inside of the cluster that takes advantage of the host namespace and host PID. It also does an NS enter and it creates a root shell on the node itself. So you can go find his tweet, he keeps it up and he revisits it. I think he revisits it every year and says, yep, this still works, like as a thread under the tweet, which is awesome. But this is policy governance, right? Like you shouldn't be able to run things like this in a real production cluster. And again, you can prevent it in a number of ways. Like OPA Gatekeeper has a mission control. Kyverno lets you, write policies. Kubernetes is the one I was blanking on. That's the JavaScript-based WASM policy engine. But you can also find a lot of this in CI. Oftentimes we want to start shifting left and finding these issues earlier. The only problem with relying too far on the CI style scanning is that a lot of people still just run kubectl, and that's not going to go through CI, right? So you have to do it at all the locations. All right, number 5, inadequate logging and monitoring. This one I probably took a page from the actual like OWASP top 10 because I think this is one of them and it applies directly into Kubernetes. Kubernetes is generating a lot of logs all the time, whether that's from your containers, the applications themselves, Kubernetes, your networking, like there's logs flying around. Most of them mean nothing, but some of them are really, really important from a security standpoint. So this is just a reminder to go kind of check out your logging infrastructure inside of Kubernetes, right? Where are they flowing to? Who has access to them? What are you looking for from a security perspective? Do you have anomaly detection? I would say after many years of doing this, when I ask the question like, oh, like what are you doing with your API audit logs? They're in an S3 bucket somewhere over here, right? That's kind of the answer where it could be used more efficiently for security investigations, right? So from a Kubernetes standpoint, the quickest thing is like your Kubernetes API audit logs, reviewing them and writing some simple detections will go a long way. Excessive forbids or users authenticating from an IP address you don't know. All of these things are really, really important, and you probably already are using these logs somewhere. If you use EKS, it's as simple as clicking a button to enable them, and it'll cost a little bit of money. And then centralizing with yes, again, all of your logs, right? So having these things in one place, whether that's Splunk, Sumo Logic, Datadog, and then runtime detection tools, right? So all these things are really important as you enhance your logging capabilities.
You don't happen to have like a recommendation if there's some, open source tools or something that would do some of this basic monitoring for you? I'm not a Kubernetes expert by any means. Don't know a lot about it, but I know our Kubernetes, the logs generated are just overwhelming.
Yeah.
In terms of, wasn't my choice, but it was one of our security ops choice to stop ingesting them in the Splunk because they were just.
It's one way to spend a lot of money.
Right, so we're thinking of using Cribble, maybe filter them out, but it's if there's, I didn't know if maybe there's something out there that would just get started on how to filter out the noise and get to what's really.
Yeah, and open source, not much, but like if you're a Datadog customer, like they have native integrations, but you're gonna deal with the same problem in Datadog where they will welcome your logs gladly into their system, but you're gonna pay a lot for that.
Yeah.
From an open source perspective, I can share some links. There are some in the top 10 actually of that section in the GitHub repo. There are techniques if you can get them into something like Elasticsearch. Full disclaimer, we've built things around audit logs and we do the pre-process. Like we filter out, it's gotta be 60% of them because you have like a health check every second of every day. It's happening constantly. Like, I don't need those, right? And like, there is definitely a list of things that need to just be like swept aside.
Wait, so that's part of your.
Yeah, we do offer that. I'm not,
Okay.
I'm not here to pitch that per se, but that's a thing. But we built it because there isn't a lot of good there's not really a great open source way to do it. And you can, depending on where you're running your cluster. So if you're using EKS inside of like managed Kubernetes, you cannot configure what is logged from an API auto log perspective. You kind of get their representation of it and you have to take it and process it later. If you're building your own clusters, you can actually just omit that stuff before it ever gets collected. But I think most people, it seems like in Nashville, use EKS, so.
Yeah.
Maybe that's
So your main concern is the amount of logs Kubernetes generates and.
Yeah, just that, like you said, 60% are just totally uninteresting, right? They're not adding value, but yet they're consuming like data as they're going into Splunk, right? So I know we'll probably end up using like Cribble in general, but still there's going to be rules we're going to have to apply to what to ingest and what not to ingest.
Yeah,
Sure.
so we use a lot of, right, in Azure, we use a lot of Kubernetes cluster. We use FileBeat as a daemon set running on every node. On the other side, we use Logstash to massage the data and then we send it to OpenSearch. So we do drop a lot of fields in the Logstash itself that we know of no use, because then OpenSearch you pay for storage, right? It's the hot tier which is tied to a EBS volume, and you pay for that. So we try to drop the news logs at the Logstash when we at the FileBeat, and that way it's of no use.
Yeah. Okay. Cool.
Do you use FileBeat to take the logs out of CloudTrail or like S3? Or are you talking about like container, like standard out logs?
Yeah, from flat files on the nodes.
Okay.
Yeah.
Yeah.
It runs as a daemon set. So.
Yeah, because I don't know if it would have access. The hard part about managed Kubernetes is getting the logs from the control plane, which is not controlled by you, controlled by AWS. Like, yeah, a daemon set can do that in your own cluster if you built it yourself, but it's hard. You'd have to reach out to CloudTrail or wherever your cloud puts them.
Yeah.
Which FileBeat might have some way to do that.
So these logs are only from your node groups, not from your control plane.
Yeah, exactly. Which are important, but they aren't going to tell you who's up to no good at the API layer, unfortunately.
I think also important to ship the kubelet logs and not only the audit logs, because a lot of time someone might be hiding by on the node itself.
Yeah, it probably is. Yes, you should be shipping all the logs somewhere and making use of them. I think most folks haven't started with the API audit logs, and the kubelet logs are just gonna be another noisy mess that has no context whatsoever. That's even probably more of a needle in the haystack, like you're digging through things that 99% are irrelevant to security. But the one thing that happens in the kubelet could be bad, right? I would say yes, but secondary to the API audit logs, if you had to choose, yeah. And like storing this stuff forever costs a lot of money, so. Yeah, it's a good point. The kubelet generates logs too. Everything generates logs. This is like, becomes this like data problem at some point. Any other questions? Didn't think logs would be the exciting part of the conversation. I'm happy about that, that's awesome. That's usually when I'm actually doing training, it's like when you start getting the head nod, like, all right, number 6, broken authentication. So if authorization via RBAC is hard, authentication is also pretty hard. And this is getting better, especially if you're like, we're gonna use an SSO provider, or we're gonna use IAM and like our managed Kubernetes, and I don't wanna do anything fancy. It's not so bad, but that's not the world we live in. People like to do weird things and set up their own authentication, and Kubernetes is no different. Kubernetes does not really care how you authenticate. Back when I started using it, we used to put usernames and base64 encoded passwords in a CSV file and then drop them onto the Kubernetes API, restart the API, and that's how you would auth to it. Like this, it was the strangest thing ever. So we just shared credentials, right? I was like, I don't care, I'm not doing that. We are in a way better place with authentication. It's very pluggable, right? So if you use AWS like EKS, you're gonna have a fairly seamless IAM experience, or setting up like Okta or AWS SSO. Any of these products work really well with Kubernetes these days, but there's still risks that can be introduced. This is just a reminder of the flow. We have humans and non-humans, right? That's the key part. Like humans are, you know, folks just running commands or debugging things, ops teams, developers, and then you have these service accounts, authentication, authorization, then admission control. Does anybody know what admission control does? We heard of this a little bit. What's it do? I knew you didn't sign up to come answer questions.
Validating or mutating, so in that terms, it's probably validating that you can actually do it, because you can catch a lot of API requests and then like being some sort of a man in the middle.
Yeah, it's basically like breaking the request before the workload gets scheduled or the request is completed, and checking it against either is it, you know, validating, or do we want to mutate it, and you can change it. It's also really interesting when you look at RBAC as an aside. You have to check if your RBAC policy allows a service account to create admission control webhooks, right? Because if I have the permission to create anything in that last pillar right there, I can mutate any incoming request, replace your container image with mine, and it's game over, right? Like it's a very, very powerful permission that no one really looks at with, you know, that in that depth. So authentication, you know, really it's like follow the best practices. Don't do things out of the norm. If you can't avoid using long-lived certificates, that's good. If you can enforce MFA through either your identity provider or SSO, try to keep service accounts inside of the cluster to access the Kubernetes API, not from the outside. And yeah, short-lived tokens are good. There's a push here towards like just-in-time access, right? I mean, kind of in that zero trust realm where you on the fly can spin up RBAC policies or users to have access for like an hour, and then it goes away, right? It doesn't even exist anymore. That's probably where the world is trying to head. I'm not really there in Kubernetes quite yet, but that would be nice. Personally, I would think that's a good approach as well. Number 7, so missing network segmentation. So Kubernetes itself does not, it has lots of networking capabilities, but it doesn't give you any capabilities out of the box to carve out that network, right? So when you spin up a cluster, pod A can talk to pod B can talk to pod C, it doesn't care, right? Now, there are ways to make a very buttoned up tight network, right? And segmented network. We'll talk about those, but just know that most of the clusters you're gonna interact with, unless you have somebody that's built those policies, that's just how they work, right? So if you compromise a pod, assume that pod is gonna be able to scan the entire network that it's in the cluster and do whatever it wants, really. Like traversing throughout a Kubernetes cluster is not difficult, unless you put some controls in place. So in this case, this is kind of the classic example where WordPress is always, I don't know why everything starts with WordPress.
30% of the. It's not true.
There you go, yeah, it's true, I guess it is the entry point, yeah, it's Jenkins and WordPress just lit. Yeah, when you build your WordPress containers with Jenkins, that's the winning combo. So if you're running WordPress in this example in Kubernetes, which sure, go ahead, and that's compromised, right? You think about it, the attacker is sitting inside of a container, right? That container might have access to things. I assume if you're running WordPress and Kubernetes, it's probably not exactly buttoned up. So an attacker's gonna start running curl, it's gonna start running wget. The idea would be to start poking around the network around you and see what else is open. Like, I wanna get off of this pod and move somewhere else. So you could find maybe Redis, right? No one also seems to put authentication on Redis. It kind of just sits there and does its thing because it's Redis and that's just what it does. So if you find port 6379, you're going to be able to modify the data, delete the data, like use Redis as a user because there is no network boundary, right? And you can do that to any other microservice running in the cluster. Preventing it is kind of a choose your own adventure sort of situation, right? The sort of hammer approach to this is just spin up another cluster, right? If you were like, these things shouldn't talk to each other, so I'm just gonna have a separate cluster. We've worked with people who do that. They just have hundreds of clusters and they all kind of do one little thing and it's like, that's cool, but that sounds like a nightmare for other reasons.
Yeah, customers who do that.
Yeah. I mean, the blast radius is contained, but then you end up with clusters that all look a little different. So you can do that, and it makes sense in some capacity to do that. And then native controls, if you've heard of something called network policies, these are built into Kubernetes, but they have there's a caveat to that. You can't just assume that you can run network policies without having some sort of network plugin architecture in place. There's a service mesh, right? That was the hot thing like 5 years ago. I feel like people kind of gave up and it is what it is now. And there's a bunch of drama now with Linkerd. I don't know if you've seen that, but they're like a CNCF project in the service mesh space, and then they decided to just make it commercial only, like their latest release. It's a whole, it's an amazing case study in open source, but Istio would be another really popular service mesh. These are all valid and they all work to restrict network traffic, right? But again, the important part is doing the work to make it happen. So, like for our clusters, we run Istio for a variety of reasons, and we tend to use these authorization policies in a lot of ways. If you want to use a pure kind of Kubernetes native approach, the network policy works all the same. You can start pretty wide. A lot of folks, I've even seen people who just have the default denied. Developers have to go explicitly ask basically through code for permission for their workloads to talk to other workloads. You can do this by namespace, you can block egress, you can block ingress, even methods, right? You can see in this Istio authorization policy. But these are firewall rules as code, essentially, with Kubernetes concepts wrapped around them. There are now open source tools, and you can see them in the top 10 that will start to learn behaviors of your traffic and try to generate these for you. They may work, they may not. That is an option, and most of our cloud providers that you're using will offer either a service mesh or a networking plugin or both as a checkbox, right? You could go to EKS or AKS and they're gonna have some capability here, but it's still up to you to build the policies. You can also get yourself into a lot of trouble by using these, as one can imagine. And you can break a lot of things. So proceed with caution, cast a wide net, but it is important to think about the different service tiers that you have from a network perspective, right? Any questions there?
One of the icons you had on the screen was for Hubble. Do you have any?
This is Cilium?
Yeah.
Oh, yeah.
That Hubble project.
Yeah.
I don't recognize the other two, but I feel like I should.
This is Istio and this is Linkerd.
Okay. I've used Linkerd before for different reasons. Don't have any first-hand experience myself with Istio. Have you know anybody who's used Hubble in production and what's their thoughts? That's the Cilium project.
Yeah, I know people who use Isovalent in production. Yeah, and I think Cilium's kind of won the networking stack add-on game, if that was a game people are playing. It's performant. I know, it's eBPF based. I think the feedback on Cilium is really good. Yeah, it offers a lot of like inspection capabilities. We only use Istio because we have some Istio in-house expertise, and like it's a bit modular. Like you don't have to use all of Istio if you don't want to, right? We use it for like distributed traces and our ingress, but we haven't turned on some of the other bits and pieces of it. But yeah, so the Cilium project's like baked into Azure these days. It's like, Isovalent was purchased by Cisco, so take that for whatever it's worth. And then Isovalent maintains the Cilium project. And Cisco, in my mind, doesn't always keep things around, but we'll see. Yeah, that worries me, but I think overall Cilium's a pretty rock solid project.
Awesome, thank you.
Yeah. Secret management failures. So I think there's secret management failures in every part of the stack. Kubernetes just does some strange stuff. And it, skip that. So at its, that was a dupe slide. Yeah, no, it's not actually. Yeah, so this comes back to how Kubernetes handles secrets. It uses the best encryption algorithm known to security, base 64 encoding. That's supposed to be a chunk. But we base 64 encode secret values, and they get stored in etcd. And etcd is the key value store that sits on the control plane, and you pull those secrets in just like any other configuration. Like you could do a kubectl get secrets or put it in your YAML manifest. That is okay, but it's a little shaky from a kind of separation of duties perspective. So most folks will use some, some other secret management store or sealed secrets or KMS built into your cloud. There's some other mechanism where the ultimate resting place for the secret sits and not base 64 encoded in etcd. Service accounts are actually like a form of secrets, right? You can find them at var run secrets, Kubernetes service account. And my problem with secrets is it's not so much that they're sitting in etcd, it's the fact that they're mixed in with everything else, right? Like all of a sudden, if you want to use Kubernetes secrets natively, you have to have RBAC that's pretty locked down, right? Because you don't want to give everybody access to just dump all the secrets immediately. I think it's just a problem that's sort of being solved by open source and commercial vendors at this point. HashiCorp Vault has some really kind of intuitive init sidecar containers that will inject secrets on the fly. Sealed secrets and things like that work too, that integrate with KMS or some of your cloud provider key management stores. But just be really mindful of like where these secrets end up. We've even seen them sitting in YAML files in people's GitHub accounts, right? Like, because it's really easy to do that, where you're just like, it looks secret, it's base 64 encoded, I accidentally checked it in, and now it's in like GitHub, it's in the revision history. It's a whole mess, but it's something to watch out for. And I wish I had a better solution, but really the solution is just don't store them inside of Kubernetes if you don't have to. And make sure you're logging, logging who's accessing the secrets, right? Back to those Kubernetes API audit logs. Jeremy's like midnight doing kubectl describe secret production 1 over and over and over again. That's a problem. Because he's gonna be able to get that secret value and use it elsewhere. And you know, if you're not looking at those logs, you'll never find it. You can encrypt secrets at rest. That's easier now. It's definitely easier in managed Kubernetes. It's even better to just use like KMS, and then runtime detection can help. Here's some examples of projects. I'm not recommending one over another. I have a bunch of experience with SOPs from Mozilla at the top, sealed secrets, HashiCorp Vault. These things get a little complicated when you start doing what are called init containers and like taking the secret and injecting it in and then making the container go away. But they do work, and they're a valid solution for secrets distribution. All right, misconfigured cluster components. So another layer of misconfiguration. So that's what I'm gonna skip. These are the components that build Kubernetes themselves. It's very dark out there. And these are things like the kubelet, the Kubernetes API server, anything that's creating the Kubernetes cluster. Now, is anybody building their own clusters, like from scratch, DIY? No.
Hops, right?
Cops, yeah, using like KOps or kubeadm or other strange bash scripts that are glued together? No.
We probably have some of that, maybe some years ago. Still very much used. So
if you're doing that, this probably goes from number 9 to like number 2, because it's hard, right? Like the kubelet itself, if you actually read the docs and like there's got to be like 150 individual config like tweaks you can make, and some of them are super gnarly. Like it'll just say allow anonymous authorization equals true, right? And like you can set up Kubernetes to do some very strange things if you are in control of the Kubernetes API or in control of the kubelet. That's why when people are running KOps or like building like homebrew like Terraform configs to like mint their own clusters, you have to actually look at that stuff. But if you're using AKS or EKS, you're kind of presented with some options and you either take them or leave them, and none of them are quite as damaging as what you can get yourself into when you're kind of building your own clusters from scratch. If you follow Kelsey Hightower, if you've heard that name, he wrote a whole Kubernetes the hard way like years and years ago. And you know, if you're bored and that's what you want to do, you can follow that, spin up a cluster every piece by piece, the CA, the kubelet, like downloading the binary from the Kubernetes site for the kubelet, compiling it, installing it on the node, and like connecting all the pieces. And you'll see pretty quickly how much you can mess up. So I would just recommend not doing that. And try and use managed Kubernetes, the classic meme. Preventing it, you know, you can still get in trouble with managed Kubernetes for sure, especially from a workload standpoint. The CIS benchmarks exist, and there are scanners that exist that help you assess your own like on-prem DIY clusters. We built a tool called K-bomb, because everyone's on the bomb hype train, that will actually interrogate the Kubernetes API and dump out a structured format bill of materials for your cluster. So you can generate a cycle in DX kind of verified spec of a cluster, and it's going to have your node versions, your API version, all the images, all the metadata, the kubelet version, everything in this giant file, and you can use that to kind of do an asset inventory or run a diff against your clusters to understand how things are configured from a lower level, right, of the Kubernetes components themselves. Okay, number 10, the final one, outdated and vulnerable Kubernetes components. So we've seen more CVEs related to the Kubernetes ecosystem last year than I think any year combined doing this. And it's because the ecosystem is growing, right? Argo CD seems to be in the news the most for this. That's not to say Argo is a bad project, but if you think about Argo CD, and if you haven't used it before, it's basically automated deployment that runs inside of your cluster. The two big ones are Flux and Argo, and Argo enables you to just give it a GitHub repo, and it'll just deploy stuff, right, at the highest level. But it has a bunch of access, right? It's implied that Argo can do a lot of things. So when Argo has a CVE or a 0-day, it's kind of a big deal, and you may want to pay attention to that, right? If you see something come out in that realm, you should definitely take a look. And there's other ones too. Ingress Nginx had two really weird CVEs that weren't CVEs for a while, and then they were just like simple flags that if you just configured in one special way, it basically was like a full bypass of Ingress Nginx and some of the controls it had from a routing perspective. It's just we're seeing a lot of things in the ecosystem that lead to problems. So kind of to wrap things up, and we can continue chatting after. Happy to stick around. Obviously, here's your list again, another list. Take a look at your clusters, right? Like we have some tools on the top 10 project per category. You can check them out. You can talk to me, and it's something to crack open, right? I think when we treat Kubernetes as a line item and like a cluster is just like either secure or not, you're missing quite a bit that's going on under the hood. Hopefully that was useful and worthwhile. I'm always available. That's my Twitter handle that I'm not as active on anymore, but you can find me very easily. If we're LinkedIn friends, I apologize in advance for all of the pictures of my face and things that will appear there. But yeah, please reach out, and thank you for coming out tonight. Thanks for having me.
Thank you, Jimmy. Well, I'm gonna stop the recording. Everybody, please hang out. I think we have scheduled until 7. So until then, enjoy food, chit chat, hang out. Otherwise, thank you for coming.
Thanks for rebooting the chapter.
Yeah.